Hi guys, this is Divyansh Gupta, CAT 1900 percentiler from IIMpact.mba. For your benefit, I have launched a free course for the CAT 2025 most probable questions. Check the link in description and enroll now for free. So what I want to do is we have 12 previous year CAT questions coming up on AMGM, 12 in 7 years, so it's a good ratio. All of these, because right now you know that we are discussing AMGM, you would be able to figure out what has to be done. So what I want you guys to observe is, what did they try to hide? The positive hint, the sum product hint, or the max minimum hint? Which of these hints is direct, or which of these things hints are hidden? So we will write D or H in front of these three. Are you clear on the assignment? The actual solutions we will be able to discuss. All right. So first question. The cost of fencing a rectangular plot is 200 per feet along one side and 100 per feet along the three other sides. If the area of the rectangular plot is 60,000 square feet, then the lowest possible cost of fencing all four sides is, first of all, uh, positive situation. Did they give it to you directly, or did they hide you? Did they hide it? They hid it, right? Areas, lengths, rupees, they have hidden it. But can you see that the positive constraint is there? The sum product thing, did they directly give you that the product is constant, or did they hide it in the area? That area is going to be 60,000. So they have hidden some product also. The max minimum is where they made a misstep. The lowest possible cost of fencing all four sides. This is direct. They have directly asked you for maximum or minimum value. So this you can then solve after this. So the cost of fencing on a rectangular plot, 200 per feet along one side. So you can say that this is 200 per feet side and 100 per feet along the other sides. So A, B and B. So your cost is going to be what? B into 200 plus 100 into 2A plus B. This is going to be your cost. A into B is fixed at 60,000. So you want to minimize 200, 300B plus 200A is going to be greater than equal to 2 times cube root of, square root of 300B into 200A. A into B is given to you, so this thing will turn out to be a perfect square, and you can find the cost from here. This will actually be 300 into 200 will also come out to be 60,000. So this is 60,000 square. So the square root of that will be 60,000 only. So 60,000 into 2 will be your lowest cost. So 1,20,000. Once you know AMGM is going to get applied, it is pretty easy. You just write what is given to you write the constant term, and then you rearrange it in the AMGM format. Clear on this? So positive hint hidden, some product hidden, but max minimum was a giveaway here. Can we move ahead? Apart from this, obviously, I covered this in your common AMGM situations also, right? The second slide where we saw which are the common AMGM situations. So area perimeter, it's a common thing. All right. For real x, the maximum possible value of x by under root 1 plus x to the power 4 is. So what about the positive hint? Is it hidden or is it given? It is actually implied that, boss, if you are finding the maximum possible value, then by default you are going to take x as positive, right? Because denominator is always positive, and if you take x as negative, you will go in the negative direction. So your maximum possible value can be a positive. If it can be a positive number, then you should try for that. So this was extremely well hidden. The fact that AMGM can be used here, it was very well hidden. Secondly, some product. Is it hidden or is it given? It is also hidden. They could have given it to you like x square plus 1 by x square, in which case it would have been, very easy to observe. But what they have given you is this. If you bring this x in the denominator, you will get 1 by root of 1 by x square plus x square. This is given. This was very well hidden. Finally, max and minimum is where they again, took a misstep. Maximum possible value immediately, rings something in me that boss, maybe AMGM is something that I can apply. And then by looking at the expression, my immediate thought is that boss, let's send X inside. Clear? So, the minimum value of the denominator will give you the maximum of the overall. And the minimum value of the denominator is what? Root 2. Inside's minimum value is what? 2. This, 1 by x plus x, minimum value is 2. So, 1 by root 2 is going to be your maximum value that you can take. X and Y are, okay. So, positive hint. X and Y are positive real numbers. Given. Direct. X plus Y satisfy 102. Direct. Then the minimum possible value, direct. This is a triple D across. So you can apply your AMGM on this directly. So this will give you 2601 into 1 plus 1 by X plus 1 by Y plus 1 by XY. Correct? And this actually, if you take the LCM, this will become XY, and this will become XY plus X plus Y plus 1. And X plus Y plus 1 is what? 102. So this becomes XY plus 102 divided by XY into 2601. Correct? And this becomes 1 if you open this up, 2601 into 1 plus 102 by XY. So X plus Y is fixed. You want to find the maximum value of XY to minimize this expression. So that will happen when X is equal to Y. Yeah, sorry. This will be 102 plus 1. So 103. You can write this as 103. That is fine. So the minimum will happen when X is equal to Y, or X and Y are 51 and 51. So you can get your answer from there. So the answer will be what? 2601 plus 103. Because 51 into 51 will be 2601. Okay, moving ahead. Let ABC be a right angle triangle with hypotenuse BC of length 20. If AP is perpendicular to BC, then the maximum possible length of AP in centimeter is. So ABC is a right angle triangle with hypotenuse BC of length 20. Positive is hidden. The fact that they are positive, it is something that is hidden here by virtue of using lengths. Some product is constant, it is also somewhat hidden. That a square plus b square is equal to 20 square is equal to 400. This is what they have actually given to you. This is also hidden. Maximum, minimum. This is a giveaway. So again, the fact that they are hiding these things, it's not the concern for us. As long as this part kicks in, you would be able to work these two things out on your own. The issue comes when this part doesn't kick in. So this one is direct hint. After this, I think this is pretty straightforward. If this is your triangle A and B, and this is AP, right? Hypotenuse is BC, this is A, this is P. So AP into BC by 2 would be the area, which will be AB by 2. So AP into BC is AB. AP turns out to be AB by 20 here. You also get A square plus B square is equal to 20 square, which is 400. So you can write 400 by 2. A square plus B square by 2 is greater than equal to AB, which is 20 AP. So you directly replaced arithmetic progression. Correct. So this will become 200 by 20, that is 10. Or you can just once you know that AMGM is going to get applied, then you can just take this as 45 because this will happen when A is equal to B. So that is also something you can do. Half of the hypotenuse, this will become the center if it's an isosceles right triangle. All right, moving on. Rectangle with the largest possible area is drawn inside a semicircle of radius 2 centimeter. The positive fact is hidden. Then the ratio of the length of the largest to the smallest side of this rectangle is. Now, where is the maximum slash minimum hint given to you that they are asking you for max or min? Can someone tell me? Is it in the first sentence or is it in the last sentence? It is in the first sentence, this largest possible area. This gives you the hint that they are not asking you to apply AMGM to find something. They are asking you to ensure the equality in AMGM, that the largest rectangle which can be drawn is being drawn, right? So this was hidden. Max minimum was honestly hidden, uh, or direct. It depends how, how much control you have over geometry. And some product again is also something which is very well hidden. This is a sort of question where until you make the diagram it's going to be difficult. So that diagram would look something like this. Now this would be the center. Let's say this is A, this is B. Now do you see A square plus B square is equal to 4 centimeter, basically radius square? And are they asking you to maximize 2AB? So now do you see that AMGM can be applied? A square and B square, A square plus B square is constant, and you want me to maximize 2AB because this side would be 2B and this side is A. So basically you want me to maximize AB. When will that happen? When A is equal to B. Correct? Equality will happen when the terms I'm using to write AMGM are equal to each other. So A square is equal to B square, or A is equal to B, which means the ratio of the side is what? 2B by A, which is 2:1. Okay, value of log A by B base A plus log B by A base B for 1 less than A less than equal to B cannot be equal to. Now let us understand what is being given. First of all, is the max min something that they have directly given you? Or is this one of those situations that are described in that table? That instead of asking you for max and minimum, they gave it like the value cannot be. So this is hidden. Positive part, is it hidden or given? It is hidden inside the log. It is not direct. I mean, they have not said positive, right? It is hidden in this combination. This will become 1 minus log B base A, correct? Plus 1 minus log A base B, or 2 minus log B base A plus log A base B. So the fact that A is greater than 1, you know, and B is greater than A. So this value is greater than 1 and this is 1 by that value. Correct? So both of these are greater than 0. Because B is greater than equal to A, this value will be greater than equal to 1. So it will be positive. So this is what they have given me. So the positive aspect was also hidden. Some product was also hidden because I have to arrive at this expression. And now I can see that the product of these two terms is constant. It's fixed. So this is basically what? 2 minus some value y plus 1 by y. And the minimum value of this is what? 2. So the maximum value of the expression is 0, which means you cannot take any value above 0. So this can be taken, this can be taken, 1 cannot be taken. Your maximum value becomes 0 because what you are looking for is 2 minus y plus 1 by y. So the minimum value of this will give you the maximum value of the overall. So this honestly was a good question for AMGM. Pretty much everything was hidden. The only giveaway, for me was this A by B and B by A, because the moment they gave me this, I wanted to separate it and converge it into this format. And then if they had given you this in the starting, it would have been a much easier question. A lot of people would have solved this. All right, moving on. The minimum possible value of x square minus 6x plus 10 divided by 3 minus x for x less than 3 is the positive constraint hidden? Yes, it is hidden, but it is not hidden sufficiently. Basically, this can be written as 0 is less than 3 minus x. Basically, 3 minus x is greater than 0. So now immediately I feel like working on 3 minus x and not x. So instead of trying to make AMGMs in x, I would try to make it in 3 minus x. So this I will now write as x minus 3 whole square plus 1 divided by 3 minus x. So this I can then write as 3 minus x plus 1 by 3 minus x. Correct? So once I do this, you know, I know that some product is constant, it's directly giving me the answer as 2, that the minimum value will be 2. Uh, Max minimum is something they had, given me in the statement. So this was a sort of giveaway here. Positive was hidden, but not very strongly. And some product, it turns out 3 minus x was the key. That instead of, working on x square minus x, working on x, I would work on 3 minus x. And the reason for that is, why would they give me x less than 3 unless they want me to apply AMGM? Because tell me, folks, what is the other method to solve this? The other method would have been that you equate it to capital Y, right? And that does not require any constraints on your domain, does it? So you can equate to Y regardless of what X is. So the reason for giving this would be that you don't do that, you instead use AMGM. Yeah, they want you to apply AMGM in this question. Correct. All right, moving on. C is equal to 16x by y plus 49y by x for some non-zero real numbers x and y. Then C cannot take the value. Now, this is an important, question. So if x by y is positive, then 16x by y plus 49y by x divided by 2 will be greater than equal to under root of 16x by y into 49y by x. Correct? Or this will become 4 into 7 or 2 into 4 into 7, which is greater than equal to 56. Correct? So basically, instead of working on x and y, I am working on x by y. If x by y is negative, if x by y is negative, then what will you have? Less than equal to minus 56. And again, if you are comfortable with what we discuss, that is fine. If you are not, you can just multiply this with minus 1 and minus 1. So what we actually did was, so I want to write this for 16x by y plus 49y by x. Now I know that x by y is negative because x by y greater than 0 case I have already covered. So if in negative I can't apply AMGM, let me multiply it with minus 1. Correct. I will write my AMGM for this. So minus 16x by y, which is positive, plus minus 49y by x, which is positive, will be greater than equal to 2 root minus 16x by y into minus 49y by x. Y cancel, x cancel, minus minus cancel. Greater than equal to 56 is this term. Now I will again multiply this minus 16x by y plus minus 49y by x with minus. So this will give me 16x by y plus 49y by x. This is what I wanted. Because I am multiplying with a minus on both sides, I will flip the inequality. So I will call it less than equal to minus 56, which is what we arrived at. So you can't really take a value between 56 and minus 56, which is what the point of my graph was that I showed you in that slide, that you will have a mod value, a magnitude, which will be respected on either end. So you can find it for positive and then reciprocate for negative. You can't take a value in between when you are applying AMGM for this format. So you can't take a value between 56 and minus 56. That is only one option, minus 50. So this is probably one of the only situations where the negative part of AMGM was actually tested. So this actually is a unique question in that sense. Can we move ahead? All right. If the sum of squares of two numbers is 97, all right, some product already given to me. All right, this is direct. Then which of the following cannot be their product? So it's a very, half-ass attempt at hiding the max minimum, right? Which of the following cannot be product? But because they have given this to me as constant, I'm already thinking of AMGM. So I don't really, think of this. So this was hidden. Positive was also, sort of hidden within squares. But at this point, you might be wondering, sir, squares are positive as much as, just write it. This is something we clearly know. So 97 by 2 is greater than equal to the product. So the product will be less than 97 by 2, which is 48.5. So the answer will be 64. If three sides of a rectangular park have a total length 400 feet, so the perimeter is fixed. So again, some product is hidden, but not in a very strong way. Then the area of the park is maximum when the length of its longer side is. So area is something we have to maximize. Summation is something which is fixed. So this becomes, these two together becomes very direct for me. And positive is something which is sort of hidden when the lengths, etc. But I mean, by this point at this question, is it really hidden anymore? Right? All right. Sum of all possible values of x satisfying the equation 2 to the power 4x square minus 2 to the power 2x square plus x plus 16 plus 2 to the power 2x plus 30 is equal to 0. Now, when we had initially discussed this question, folks, in our, quiz, we had converted it into a whole square. And even I didn't think of, AMGM in this particular scenario. However, 2 to the power 4x square plus 2 to the power 2x plus 30. Let me separate this. These two are positive, correct? 2 to the power anything and 2 to the power anything. This is positive. This would be greater than equal to square root of this into this, which is 4x square plus 2x plus 30. Correct? Which you can write as 2 to the power 2x square plus x plus 15. This is the square root of this. And if I take this 2 to the other side, I will multiply this 2 with this. So basically increase this 15 to 16. So basically what I'm getting is 2 to the power 4x square plus 2 to the power 2x plus 30 is greater than equal to, is greater than equal to 2 to the power 2x square plus x plus 16. Which is what? The minimum value of these two sum is actually equal to this. So this can only happen when you have equality, or 2 to the power 4x square is equal to 2 to the power 2x plus 30, or 4x square is equal to 2x plus 30. Correct? After that, you can find your answer. So even I had missed that in the first time we had discussed this, but today I was going through all the PYQs. The important part is, which I would want to bring your focus to. Nothing was really given to you. Some product is actually not constant if you think about it. Right, 2 to the power 4x square plus 2 to the power 2x plus 30 is, some product is not really constant. Positive is something which is hidden. All right, and max minimum is something which they didn't ask about. So the only reason why I thought of this is that this is f of x is equal to gfx sort of situation, which again I described. Correct. And in this scenario, minimum of this is equal to this, or maximum minimum, or in a reverse scenario, that is what will work. See, the likelihood of this clicking is difficult until someone shows you this. However, now that I have shown you this, this might be something that you can think of. I will tell you why I thought of AMGM here. So I didn't see Priyam's message. I must have missed this. The reason why I thought of AMGM in this scenario, in question this one, is because of this question. This is also the exact same thing if you think about it. F of x is equal to g of x. The minimum value of f of x is 2 and the maximum value of g of x is 2. Correct? Which means that they will have to individually at the same time be equal to 2 to be equal to each other. And that cannot happen, which is why the number of solutions are 0. This is what led me to categorize f of x is equal to g of x situation, and then I tested again if there are other situations where I can apply that, and this turned out to be one of those situations. Will that strike it in the exam? Before this class, maybe not. After this class, probably yes. All right. This is the last question this we have discussed in the previous class. So this is not technically an AMGM question. What this is that the rejection. So the AMGM comes in the rejection part, so it can lead you to cause some errors. So this is y square minus 3y plus 2, which means y is equal to 1 and y is equal to 2. Corresponding to that, x plus 1 by x is equal to 1 and x plus 1 by x is equal to 2. So people would have thought I will get two values of x from here and two values of x from here. So people would have marked 4. Some smart people would have thought that I will get two values from here, but I will get only one value from here because this is perfect square. They would have marked 3 here. The actual answer is x plus 1 by x can never be equal to 1, right? Uh, so these two are non-existent. The only solution is this: x plus 1 by x is equal to 2, which happens when this is the lowest value. So you should actually mark 1. This is one of those questions, takes you 30 seconds, 40 seconds to solve. You mark it in the exam, you are confident, one question I have done. And, when you look at your answer, it becomes 0. So what I'm saying is you replace x plus 1 by x with some number capital Y. You get y square minus 3y plus 2 is equal to 0. This you can factorize as y minus 1 into y minus 2 is equal to 0, which will give you y is equal to 1 and y is equal to 2 as roots. Now, people would think that y is what? X plus 1 by x. Correct. So x plus 1 by x is equal to 1 will give me two values of x because a quadratic will become, and x plus 1 by x is equal to 2 will also give me two values of x. So people would have marked 4. Some smart people would have realized that the second one, x plus 1 by x is equal to 2, will actually give you x square minus 2x plus 1 is equal to 0, which is a perfect square scenario. So you will get only x is equal to 1 as your answer. So one solution here and two solutions here. Some people would have marked this 3. But the actual answer is, would x plus 1 by x be equal to 1 ever? No, right? So there would be no real value of x here. So the only possible solution is coming from x plus 1 by x is equal to 2, and that is only one solution.